Hello, everyone. Good morning. So basically, I am here to present a session on the daily roles and responsibilities of a DevOps engineer. In turn, basically streamlining the development and the operations wing. So to start with the session, I'll basically introduce what the different topics we'll be touch basing upon in this session. So first is the daily roles and responsibilities of a DevOps engineer in a particular MNC, and how they help in bridging the gap between the development and the operation, as the name suggests, DevOps. So development and the operation tasks which are performed for a particular software development lifecycle, and the key level or the high level attributes of the DevOps model, which are being followed to implement these processes, these integrities of the DevOps environment. So to begin with, the first question arises in one's mind is what is DevOps? So if we go by the definition of DevOps, so it is a set of practices that combines software development, that is the dev part of the DevOps, and the operations associated to it, that is the operations part. And why we implement this approach, or why we uh, cater basically the software development lifecycle with this approach is to improve the speed, quality, and the reliability of the software releases and the various deployments which happen due to different business requirements throughout the year. So, to cater to all those needs in a fast manner, in a reliable manner, the DevOps approach or the DevOps model is implemented and is integrated with a particular setup of the software development lifecycle. So the key principles which mainly are comprising or basically related to the DevOps model is the collaboration which happens between the DevOps team and the development team, and again with the exact operations team which handles the production environment. Then the automation, the different levels of automation at different stages make sure that whatever code we have developed is going or passing to the next stage in an automated fashion with proper testing, so that the delivery time would be faster. Then again, the continuous integration and continuous delivery approach, which on a continuous level keeps on generating new code and maintaining its delivery also with proper testing and to the proper environments where it can be further tested by the testers of the functional and business logic. And one major part which is there, or the key principle which is there, is the continuous monitoring, so that the continuous feedback can be given to the development team, so that if there is any glitch in the code quality or there is any misses which were made, those can be rectified well in time and those can be resolved before that code or the piece of code goes to the production environment where it could impact in a very bigger way. So all these are the key principles. And if we talk about the various tools which can be used, now again, I have listed few of the tools here, but there are many tools in the market available, and all of those have some or the other advantage over the other. Basis the requirement, basis the implementation approach, a particular tool can be selected and can be taken benefit from. So in terms of versioning, similar to Git, there is a tool called Bitbucket. So that is used. Bitbucket gives a web-based UI. So a thing, or basically a particular file, be it a YAML file or any XML file, can be edited, enhanced, modified directly on that web-based URL or the web-based view. So that liberty we get from Bitbucket. Then we have the CI/CD pipeline structure, which is often used for the DevOps approach, and tools like Jenkins or TeamCity can be utilized to have that approach implemented, and various automation uh, stages are implemented in a particular pipeline so that the code delivery and the testing of the particular test cases can be fastened upon, and the final build of the package or the new version can be provided to the next stage or the environment where it is to be deployed. Then for deployment, there are again many tools, but one of the famous tools is the IBM Urban Code Deploy, mainly or very famously known as udeploy. So that is also used in terms of deploying the final version to the respective environment wherever the need is there to test the business and functional logic. And apart from them, as continuous monitoring is a vital principle. So monitoring in terms of the resources on a particular environment or the application logs of the newly deployed code. So all these plays a very important role, and different tools can be utilized to have this monitoring in place and can be benefited from. So if we move to the next slide, so these are the daily roles and responsibilities of a DevOps engineer working in a IT MNC, and he has to manage all these different attributes aspects of a DevOps approach. So managing and maintaining the CI/CD pipelines is one of the uh, key role which a DevOps engineer does. Then if we go to the next role, it is the smooth testing and the deployment basically. Then again, ensuring the infrastructure scalability and reliability is one of the key aspect, as wherever the code is going to be deployed finally after passing all the test cases and the code quality. So wherever the code is getting to deployed, so that infrastructure should be well in term or well versed with that with the handling of that particular piece of code. If the infrastructure is not up to the mark, there will be many issues which we can see, and whatever code we have developed, that won't be properly working upon that environment. So ensuring the infrastructure is a very key role. Again, monitoring and troubleshooting of the application performance is again a very key responsibility, that whatever deployment is done to that particular environment, that needs to be properly monitored, and in case of any issues are arising, we need to troubleshoot them, fix them as soon as possible so that that particular environment can be made available, and the further testing or further functioning upon that can be worked. Now the fifth key role is implementing security and compliance measures. So as in a particular application or in a particular environment, many interfaces talk to each other for any business flow or for any functional flow. So making sure that all the encryptions or basically the security standards are in place. So we have to maintain and implement the security and compliance measures so that all those aspects are completely covered and our environment and the code is properly secured. Sixth key role is collaborating with the development teams to improve the code quality. Now, the continuous feedback from the DevOps team and basically the operations side of the DevOps team helps in uh, generating or basically improving the code quality by the development teams so that lesser misses and almost foolproof code can be deployed to the next stages, and there shouldn't be a back and forth again and again. So all these are the key roles and responsibilities in a nutshell. So going to the next slides, we'll be covering each of these responsibilities in a deeper manner. So first was the CI/CD pipelines. So to basically uh, understand what a CI/CD pipeline is, so it is in a definitive way, it is a set of automated processes that build, test, and deploy a piece of code. Now, if we see what are the benefits we get from CI/CD pipelines or implementing this approach, are the faster time to market, deliveries, improved code quality, and the reduced risks of deployment. Now, as you can see in the diagram, I think it is readable because the image was blurred. So in the different stages of CI/CD, we can term, or basically we can categorize the stages as source, where the source code is present and we are generating a new code, or basically a particular functionality is added to the new code. So now we are enhancing that functionality and going to merge that newly generated code with the source code, with the master branch, you can say. After that, the build phase is there. Once the code is built, the test cases, the functional or the integrational test cases will be ran on that final build. And once all of those are checked upon and all of those are passed, the final build is ready to be deployed to the environment wherever it is necessary. So there are multiple environments which are there present in the uh, various MNCs we work. So it could be the production environment, it could be the UAT environment, user acceptance testing, then it could be IST environment. So there are various environments where uh, the code is finally deployed and tested before moving to the final production environment. So if we go and see the next key role is basically testing and deployment. So testing is carried out in terms of the integrational and functional test cases in the continuous integration phase itself, followed by the development to the relevant environment. So the test cases related to functional and integrational tests are written in the CI/CD pipeline itself, be it Jenkins or TeamCity or any other equivalent approach used. So functional test cases will be testing or basically covering whatever functional approach that particular piece of code has. So all the functions or the functional flow should be properly uh, executed and it should be working. Now, integration test cases helps in basically how well this particular newly built code will be integrating with the existing parameters or existing code logics which were there in the source code. So once all these things are passed, the developed code is considered to be okay to be deployed to the next stages or the next level of environments. Going to the next slide, we have infrastructure management. So now since the code is tested and it is ready to be deployed to a new environment where more regression testing would be taking place with all the resources, be it database, be it front end, all the flows, all the interfaces, or the third party applications will be tested in this regression testing environment. So once the code is deployed, or before deploying the piece of code, it is a key responsibility of a DevOps engineer that wherever the code is getting deployed, where to whichever environment, the infrastructure of that environment should be in sync with the requirements of the particular piece of code which is getting deployed there. So there shouldn't be a CPU core issue or high load or the DB connections issue. So all these things should be taken care in mind before reaching or basically deploying the code to the testing or the regression testing environment. So as per the definition for infrastructure management, it is basically the process of managing and maintaining the underlying infrastructure for the software applications. Now, the responsibilities which are vital to be exhibited by a DevOps engineer in this infrastructure management are provisioning, scaling, and securing infrastructure resources required for the particular developed code to function well and do all the requirements, or basically do all the functions which was supposed to be done by that piece of code. Again, a group of people or a handful of people, generally uh, called as an infra team, they handle all these configurations, and they uh, cater to all these requirements of the infrastructure management, which is subsequently required by the newly developed code. If we move to the next stage, so once, let's say, the code was okay and the environment was also okay in terms of the infra requirements, now comes the monitoring and troubleshooting part post the deployment of that particular piece of code which was generated lately. Once the code is deployed, the monitoring starts from there on. So monitoring basically helps in resolving the issues faster related to whatever being identified after the deployment of that particular piece of code. So if we see in a definitive way, the process which basically identifies the issues and helps in resolving the issues with the software application or with the particular piece of software deployed on the server, those come under the monitoring and troubleshooting part. Now, there are various tools. Again, I would say in the market, many tools are present for handling or basically catering to these needs of monitoring and troubleshooting. But I have listed down few of them. So in terms of application logging, so whatever application logs are getting generated, we can use tools like Splunk or Grafana. So in both these tools or approaches, basically we can have few checks being implemented, and basis these few checks, alerting can be configured, reports can be configured, dashboards can be made where we can have a look and feel of how the application is performing and how well or how many errors are coming in a daily basis or basically in a month, or whatever trend we want to see. All those things can be measured upon and can be alerted to the various teams which are basically handling that particular set of environment. Again, there are monitoring tools or basically alerting tools in terms of resources uh, which a particular server or which a particular piece of code is being deployed upon. So, be it database connectivity, be it CPU cores, be it the JVM instance which are running on the server. So, all these can be monitored through various tools. Again, there are many other tools as well, better, not better than the ones I have listed. So, Genius ITRS is one where we get a complete uh, one screen view of the application, how the JVMs are performing, how the database connectivity is there, how many uh, blocking sessions are there in the database, how many logged sessions, how many users are querying at the particular frame of time. And similar in App Dynamics, where we can see the uh, tracing of a particular call from when a button in the front end has been hit, how the call traverses from which layer to which layer, and how it fetches the information from database or whatever CRUD operation it has to do in the database. That is done, and again giving back the response which was expected. So all that traversing of logs, JVM health, server health can be monitored in App Dynamics, and again alerting can be implemented. So those alerts can be acted upon, and that gives us a better monitoring approach, basically in terms of proactively setting those alerts so that uh, the reactive time which we or which a particular team will take to fix any issue can be minimized, and those proactive alerting can be utilized to basically fixing the issue or resolving the issue at a faster rate. Now comes this security and compliance aspect of the key roles. So it is very important that whatever data or basically whatever application which is deployed on a particular server, we need to protect that sensitive data, and we should ensure that we are following the regulatory compliance which are laid by our company. So there are various activities like implementing security measures, conducting risk assessments, and ensuring compliance with regulations. So if we see a few of examples, basically, so implementation of SSL certificates. So SSL certificates are basically the secure sockets layer certificates, which are very highly utilized while we are basically communicating with different interfaces or different third parties for getting information or passing on some information to them. So a proper SSL certificate handshake should be established to have that call result in a success. Now, let's say if there is an upstream application and they are encrypting whatever request they are sending to the downstream application. So the encrypted request is encrypted by certificate A, for example. And if that certificate A is not present at the destination application or the downstream application, then the proper SSL handshake won't happen and the call will fail. So in that case, a certificate A should also be present at the destination site so that the proper SSL handshaking should be established, can be established, and basis that the connectivity will happen and the two interfaces or the two applications will talk and communicate with each other. Again, in the compliance wing comes the vulnerability assessments. So, for example, a code which was deployed 2, 3 years back, and the library versions or the jar versions of that particular functionality of code are now ha- are now have reached to the end of cycle or end of life stage. So those vulnerability assessments are in sync with the regulations laid by the compliance team. And once these applications or these uh, alerts are coming to the operations team to handle these vulnerabilities in the environment, so those particular old jars or basically vulnerable jars or library functions or the libraries are cleared upon, removed upon, so that we or the environment remains in sync with the compliance regulations and the standards. Coming to the next topic or the uh, basically the next role which is played by a DevOps engineer is collaboration with the development teams. So this is a very vital role in terms of maintaining the standards or the quality of the code which is going to the different environments and ultimately to the production environment where the end customer is going to be impacted or where the end customer is going to be uh, touched base upon. So maintaining this quality of code is becomes very important in terms of the end customer experience shouldn't be bad in terms of any app which he or she is using. Now, improving code quality is one thing. Apart from that, reducing the deployment risks and increasing the efficiency. So these three things and many others can be achieved with a proper collaboration, with a proper feedback channel, so that the final outcome of the code or the final impact of the code is a fruitful one for all the teams and for the end customer as well. So various activities which are generally followed in various MNCs for having this collaboration in practice are the code reviews.
Excuse me, sir.
Yes, team.
Yeah, just a question from our end. What could be the reducing deployment risk part? The audience is asking what could be defined as a deployment risk?
Okay. So in various environments, when we are deploying a particular code, so there are chances where though it is properly tested and things are there, but the testing in terms of the interfaces or the applications which are already there in the environment, but those are not covered during the CI/CD phase. So those should be minimized in terms of having the proper infra of the environment where the code is getting deployed and the proper security and compliance of the code so that there shouldn't be any uh, SSL handshake failures or basically the vulnerabilities in terms of any library files. So all those comes under the deployment risks, which we need to have a proper check upon, and those should be minimized. Rather, those should be negligible. But again, here and there, those risks appear, but we have to make sure that we are minimizing them as much as possible. Is that okay, or shall I continue?
Yes, sir. We have two more questions, but we'll ask you that at the end of the session.
Sure. So in terms of the activities which can be which can be utilized in practice for the collaboration are the code reviews, pair programming. So the operations engineer talking to the development engineer, and they are working in sync to basically sharing the needs and sharing all the information which should be what could be the approach or what could be the limitation which we have in this environment basis that the development can be done. So all these things comes under the pair programming. Then while we are planning or while we are in the planning phase before the sprint is started, so user story based discussions and the joint planning of whatever new functionality is being introduced or new functional code which is getting to be generated. So all these practices will help in the proper collaboration with the dev teams and in turn benefit basically in that quality standards to be maintained for the piece of code which is getting generated. So this brings me to the conclusion of various aspects. Again, this was a high level view of all the responsibilities DevOps engineer plays in a particular role or basically in a particular MNC where he or she is working as a DevOps engineer. So as we have seen through the various slides which we have already gone through, so critical role for a DevOps engineer is basically maintaining both dev side of it and the operation side of it. And basically, at the end, they are streamlining the development and operations part of the DevOps approach. Now, call to action, or basically a key takeaway, is that adopting DevOps practices will surely improve the efficiency, quality, and reliability of the code which is getting generated, and will also be making us faster in terms of whatever code is generated, deployed, tested, and made available to the end customer or the customers like you or me or anyone for that matter in terms of, let's say, flight booking, flight ticket booking system is there, flight ticket booking app is there. So for me or for all of us, it is a product which we are using, and any unfavorable outcome on that particular application will lead to unsatisfaction in the customer. So all those things should be keeping in mind, should be kept in mind, and the efficiency, quality, and reliability should be maintained so that the end customer experience can be fruitful. Yes, Neil. So if any questions are there, we can take those upon.
Yes, sir. So our second question here was the code reviews that happen, at what part do they happen in the deployment on the SDLC?
Okay. So generally, once the build is completed, basically the source code merging part is done with the newly deployed code. And now the code is done with the build also, but the integration and functional test cases are yet to be passed or basically tested for. So in that phase, the code reviews are made out.
Okay, and the last question that we have here is in the SDLC that happens, how many people are solely dedicated for this code reviewing and all of these testing aspects? Or is that a separate team that takes over it entirely?
It depends on the structure of how a particular company is working or basically handling this wing or this approach. But again, if there is a good size of people in a particular team, so generally from the operation side, 2 or 3 people which are handling this side, then the business analyst, which actually brought the requirements for the newly developed code, then the actual developer who worked on that, and the developers manager also. So around 6 to 7 people, the core people comprises of that code review meeting. So again, as per the requirement or as per the code level development, this meeting or the people basically being a part of this meeting keeps on changing as per the different roles and functions each of them are handling.
Yes, so we actually have one more question. So if there are any erratic and sudden changes and changes that are being made a lot in the SDLC in the project itself, so how is that handled in terms of the logistics behind it?
Can you come again? There was a disturbance in between.
Yes, so my question was if there are any changes that are being made very frequently and very erratically in the middle of the SDLC, so how would you approach that as a DevOps engineer?
So now the changes are in terms of the code which is getting developed, or the environment related changes.
Environment related.
Okay. So generally, let's say Java SDK, which is deployed on the server, and the piece of code needs Java for running and functioning. So there are changes where the Java version is now basically end of life, that is expiring, and that is not coming under the standards which are set by the compliance team. So now there is a need of Java version upgrade on that particular environment for on that server. So those upgrades and the deployments are well synced in terms of there shouldn't be an impact for the environment availability also, and the upgrades should also happen as per the directions of compliance team, and the deployment will also happen. So all these things are taken care in a way that none of the activity will cause a downtime for the application testing or for the regression testing. And in case of production team, a production environment, all these things are taken up during a weekend, so that there is very less consumer base which is testing the application or basically using the application. In terms of an application, let's say if it is a banking application, or if it is a travel flight booking site, so those have chances of having uh, the traffic on weekends also. So in that case, we follow approach of basically redundant environments, in terms of one set of servers will be undergoing the changes or the deployments and will be down, and the other set of environment or the servers will be up to serve the traffic. So once the deployment is done on set of servers one, the set of two servers will be made down, and this will be made up, so that no downtime practically can be possible.
Yes, so that answers the question pretty well. I would thank you. I would like to thank you for taking out your valuable time to enlighten our audience about this fascinating topic. It's a very relevant topic in today's industry, and I'm sure that the audience has loved this session. And thank you for answering all of the questions that we've posted. So, thank you very much.
Thank you. Thank you, Neil. Thank you,
Yes.
everyone who have attended this session. And I would just say that keep growing, keep learning, and all the best to all of you for your future endeavors. Thank you once again.